All right, guys, so if you look at your sheet there, first thing we need to do is figure out what we're studying and is it categorical or quantitative. So what do you think we're studying here?
Qualitative.
Okay. What are we studying? Let's start with that first. Yeah, we're looking at average gas consumption. I see the word average in the problem. So we need to figure out, is that a means or a proportion test?
Means.
Means. Okay, good start. So we figured out that we're talking about means, and we know our population. So we're going to write somewhere here what mu is equal to. We're going to define that. And it's just the true average gas consumption, and we'll use what's on your paper in Great Britain. So So we're talking about means, and when you're talking about means, that's when you have to decide, is it Z or is it T? How do we tell the difference between those two? Yeah, Max.
Based on if you know the signification or not.
Right. Do we know sigma or do we not know sigma? What do you think in this one, guys?
T.
It's a t-test, right? We don't know sigma. We have this lovely sample, and we can find S from the sample, but we don't actually know sigma. Okay, so it's definitely going to be a t-test, and you have to write down more than just a t-test. So we have to say one sample t-test for means. And guys, I'm going to go to where I have a little more space because I definitely don't have enough on this slide to write all of this. If you're going along down the little sheet here, it says make a chart of known and unknown parameters and statistics. You don't have to make like an actual chart, but we could list out the things that we know or don't know. So do we know sigma? No, that's why we picked t-test, okay? Do we know mu? Kind of. They're telling us they think it's 7 liters per day. More than 7 liters per day. So this is what you're going to use in your hypothesis, your null hypothesis. That's what the claimed true mean is, and then we're testing to see if we think that's actually the true mean. Okay? Could we find X bar? Yes. How would we do that? Yes, list 1 bar stat. All right, that's what we're doing next. So guys, get out your calculator. I'll open up mine. Question. Okay, so we're going to go into the list. And you do that just by hitting stat and then edit. And that allows you to enter values into your list. So we've got all of these to enter. should have 30 numbers entered. All right, and then we're going to go the 1 bar stat. How do we do that, guys? Good job. And guys, if you forget where something is, just push the button until you find it. Like, it's not a big deal if you're like, oh, is that under stat or not? Don't just sit there staring at your calculator going, well, I don't know if it's there. Just try, okay? You'll find it. So 1 bar stat, mine's in list 1. I don't have a frequency list. I'll go ahead and calculate it. All right, we get this 8.2 for our X bar. What else do you think I want from this list? Yeah, and it's the standard deviation of the sample. So is it the S or the sigma? What do you think? The S, good, okay. So we need those 2 numbers. Anybody need calculator help? You're not getting those values? Okay, I'm gonna move this so I can write them. So our X bar was 8.2, S was 4.29, and then our sample size was 30, right? So that's kind of all the stuff we need for the problem. All right, then it says we should write our null and our alternative hypothesis. So, any thoughts as to what the null should be? Yeah, I know, what do you think? It's mu. Yep, good. Yeah, your null is always sort of what the claim is right now. We're claiming that the true average liters per day is 7. So we're claiming mu is 7. And that null is always mu equals something, or p equals something. It's an equal sign in that one. And then your alternative is what you're testing. Like, what do you think it is? So what do you think in this one, guys? Are they saying it's greater than 7, less than 7, or just different than 7? Greater. So your alternative is that mu is greater than 7. Okay, so if you see like an alternative with an X bar in it, that's not the right way to write it. Like, you know, sometimes you have to pick on multiple choice, what's the proper null, alternative, that sort of thing. It's always got to be mu. The null is always equals. The alternative is always an inequality. Okay. Sometimes it's good to just note for yourself off to the side what your alpha level is, so you remember at the end. Our alpha level is 0.05. Troubles? You good? Okay. Perfect. All right, what have I not done yet that is something we always have to do? Conditions. Okay, so we'll check conditions. And on your little guide here, I've reminded you of what the conditions you need to check for the 2 types of data are. So we need to check random. So what do you think, looking at your problem? Stated, assumed? It is assumed. It doesn't say random in it, does it? It just says the sample. So we're going to assume. Okay. What about normal? Yeah, it's just big enough. Our sample size was 30. 30 is greater than or equal to 30, so we can use the central limit there. Yes. If it wasn't, like if it wasn't big enough, what's the other way we can check for when we have the whole list of values? The graph thing. Anybody remember what the graph thing's called? Yes, normal probability plot. Okay, that's the other way you can check. If that's approximately linear, then you know the normal condition has been checked. Okay? All right. Yeah, the graph thing. That graph. Okay, now we're ready to actually do the test. So when you do that, we've already stated what test it is. It's really good to write the formula that you're using. I'm going to go below my conditions here to do this. We're doing a t-test, so I want to write down what t is equal to. And you guys can see it on your sheet there. It's x bar minus mu over s over the square root of n. Now you do not have to fill in this formula by hand, but it's always a part of the grading rubric is, did they write the formula? All right, let's make a little sketch to go along with this, what we're actually doing. So here's my t distribution. Where's the center of my picture?
7.
7, yeah, it's what the claimed true mean is. That's what goes in the middle, okay? And what did we get as our sample mean, our x bar? 8.2, so that's somewhere over here, right? And our alternative, we said greater than that, so we want to know how likely is it to get a sample of 8.2 or more extreme, like, so you're always looking at the tail there. Okay, and then we're going to get the calculator open again. All right, so we want to go into stats. Over to tests. What test do you think I'm going to pick? T-test, yeah. Okay, and you've got choices here. You can use data or you can use stats. And really, we could use either one because we calculated our stats. Let's use the data this time, though, because I don't think we did that last class. So what is our mu that we're going to put in? 7, good. And then wherever you entered your data values, for me it was list 1, so I'm going to leave it as list 1. Again, no frequency here. And then as far as what sort of alternative hypothesis, we picked greater than, okay? And then I always recommend that you click draw instead of calculate because it gives you the picture as well. So you can kind of make sure yours is making sense. And then those two numbers at the bottom there, the T and the P, those, you need both of those, okay? Anybody not getting 1.5334 and 0.068? Okay.
My T was the same, but my P was different. Oh.
Anybody else trouble? Okay. All right, guys, so I'm going to write what the T is equal to here, which was 1.53. And then the P, that's your P value. And that was what, 0.068, I think? So guys, what all of these mean, the t, that is like your z-score, and then from that you can calculate the probability. We don't do it in all the different steps though. We just say here's your t and here's your p-value all together. Okay, we have to make our conclusion then based on our p-value. Is the p-value greater than or less than alpha? Greater than. Okay, so our conclusion, since our p-value of 0.068 is greater than alpha of 0.05. Anybody remember from last time? Does that mean we reject or fail to reject?
Fail to reject.
Good, we failed to reject. The null. There is not enough evidence to suggest that the true assumption has increased to more than 7 liters per day. Yep, that's what you'd say. You'd say, so if this had been like 0.038, you'd say less than alpha, we reject the null. There is enough evidence to suggest that the true mean consumption of gas has increased to more than 7. If it's less than alpha, you reject. When it's greater than alpha, we fail to reject. Yep. The wording is very similar. It's just omitting a word here and there. Yep, like it's like the claimed truth right now. And so what you're looking at, what this p-value means, that 0.068, that is how likely it is to obtain this sample with a mean of 8.2 if the true mean is actually 7. So we're saying with an alpha level of 0.05 that if we get anything above that, like that's a high enough likelihood for that to happen by chance. If you get a p-value of like 0.00002, like it's really, really unlikely for that to happen if the mean is 7. So we're going to say the mean's not 7. That's what the p-value is talking about. Yeah. 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 And I'll keep saying that over and over and over, like what the p-value means, because I know sometimes it takes a while for you to really understand what that's talking about. All right, guys, questions on that one? Okay, up next. So we have the teenage cell phone usage, something. Exceeding monthly data allotment. Is that what you guys have next? Yeah. All right, so it's number 5 in the middle of my page here. I know it's number 3 for you guys. Again, I'm going to go to another slide to do this one. There's not enough room here. Okay, so take a second to read it. All right, guys, do you think this is a means or proportion problem? Proportion, okay, we see proportion, all right. Let's define our parameter of interest. So, it's not going to be a mu since it's a proportion problem, right? It's going to be p. So what is our p? Go ahead, Okay, yep, so we're talking about teens that go over their allotted data, yep. And we would say it's the true proportion of teenage cell phone users exceeding, going over, however you want to word it is fine. And guys, that worksheet I passed out to you, the back has kind of a shortened version of the steps you should go through without all the formulas and everything written, but a good little guide for you walking through each of these hypothesis tests. So we defined our population of interest. What kind of test are we doing? What would the name of this test be? Is it ever a t-test with proportions? No. Okay, good. Yeah, go ahead, You're close, you're close. It is a one sample z-test for proportions. Okay. All right, next on the list it says write the parameters and statistics. So what is the claimed P right now? Yep, 65.65. And remember, that's the one you'll end up using when you write your null and alternative. What is P hat? Okay, 0.69. What is N? 225. Good. All right, then we can write our null and alternative. What do you think the null is? Good. Capital P equals 0.65. And what is our alternative this time? There you go. P is greater than 0.65. You with me so far, guys? All right, what's next on our to-do list? Conditions. All right, first up is random. I think this one was stated. Yep, a random sample. Okay. Okay, checking for normality. It's a proportions problem. Can I use central limit theorem? No, do not put that in a proportions problem. How do we check normality with proportions? Yep. Exactly. So we've got to do the n times p hat. And guys, you can't just say that and write greater than or equal to 10. You have to actually show the numbers. Okay, so we would say that's 225 times 0.69. What does that come out to be? I'm going to go 155. That is absolutely greater than or equal to 10. Then we show n times 1 minus p hat. 225 times 1 minus 0.69. 70. A greater than or equal to 10. So we are good on normal conditions. Okay. Now we just have our calculations to do. So it is a z-test, a one-sample z-test for proportions. So we want to make sure we write out that formula. We're not going to plug it into the formula, but we're going to state the formula. So your z formula for proportions, that is the p hat minus p over the square root p 1 minus p all over n. But then we'll do the actual calculation on our calculator, okay? All right, let me bring the calculator over. Okay, guys. So I'm going to go into stat. Over to tests. What test am I going to pick? What do we think? Number 5? Yeah, one proportion z-test. All right, so what is the true proportion being claimed? Basically, what's your null? That's the 0.65, right? Okay, now the thing that just usually causes you a little pause here, you can't put in 0.69, okay? It won't ever let you put in the sample proportion. You have to put in successes out of total. So what we know the n is 225, right? What does x end up being? 155, yeah. You calculate it when you do the test for normality, so it's not that big a deal. It's just 0.69 times 225. All right, and do we want not equal to, less than, or greater than? Greater than, good. And I will pick draw. Could you do what? I'm sorry. Yep. And I was just letting it draw for me first, and then I'll draw it. So, yeah. All right, are we getting 1.223 and 0.1107? Yeah. Anybody troubles anywhere? So yes, I'm going to go ahead and draw my picture over here. It's centered at 0.65. We want to know how likely is it to get a sample of 0.69 or more extreme. So we got a z of 1.22 and a p-value 0.11. right, we can name our conclusion now, or state our conclusion. So, since our p-value of 0.11 is that greater than or less than our alpha? Greater than. It's greater than alpha of 0.05. What do we do? Do we reject or fail to reject? Yeah, we fail to reject. Null. There is not enough evidence. To suggest that the true proportion of teams who exceed their allotted I don't remember if this was data or I keep saying minutes, but it's cell phone data. Do you guys even remember when like you had a certain number of minutes on your cell phone, or is that like a couple of you remember? Yeah. It's weird now to think about that. Do you guys see how the conclusion is really the same thing every time? Like it's very formulaic, okay? Yeah.
Like, even if it's percent, can leave it as.
I would leave it as a 0.11, yeah. Is that what you mean? Or you mean like the 0.65? You could say that as 65%. Either way is fine. But this one, leave as the p-value itself, yeah. Questions on that one? How are we doing, guys? Are we a little tired on a Friday? Has it been a long, short week? Why does that happen? I don't know why. Sometimes on short weeks, I'm just more tired at the end. All right, let's see. I think we're going to do one more of these next time as kind of a make sure you remember it after the weekend. We're going to do a quizzes right now with a partner to see how you're doing with the null and the alternative and kind of that stuff, all right?
With a partner?
With a partner,
Awesome.
yes.